Let me share my screen. Okay, before we discuss the topic for today, maybe I also tell you about the assignment. Okay, you could get the document for assignment 1 at e-learning. Okay, so it's over here. Okay, you could download it now. Okay, this is a assignment, group assignment, maximum 2%. Initially, I plan to make it 1, but anyway, I think it's fine, 2% maximum. Okay, the objective of the assignment is to adapt appropriate algorithm, strategy, and design in problem solving and programming. This is the main objective. The second objective is to analyze the time complexity of the algorithm. Okay, refer to the examples given in the appendix. Understand the way the sorting is being carried out. Okay, so okay, at the appendix here, there's a figure. Okay, there are figures. So there's a list of numbers. So sorting algorithm will put in this case numbers in a specific order. So after finish sorting, it will put the numbers in increasing order. Okay, the numbers are in increasing order. Okay, so understand what is how the sorting is being carried out, and then you need to implement this. Okay, so looking at the example, I think it should be quite straightforward. I mean, understanding the how the algorithm works in sorting the number in increasing order, right? Okay, this one you can look at it, understand it later. If you don't understand, you can ask me later on. Okay, so there are a few parts here, different parts. There are 4 parts. Different parts have different marks. Okay, the first part is to implement the sorting algorithm in Python. So after you implement it, name the script in sort number. Okay. Second part is to extend the sorting algorithm here. Okay. So now instead of sorting number, you change the sort number to become sorting words. Okay. So now you want to sort it in lexicographic order, the word of different length. Okay. So the first part is actually test your programming skill, meaning understand and then implement. Second part is to test your ability to extend or convert the problems from sorting numbers to sorting words. Okay, lexicographic order means sorting the string in increasing in dictionary order. Okay, in dictionary order. So beside changing from words, besides changing from sorting numbers to sorting words, you also want to expand the algorithm so that it can sort words of different length. So if you look at this example, the example given, the numbers have the same length, okay, have the same length, have the same number of digits, okay. So this example only show you sorting numbers of same length, okay. So now in second part, you have to modify the algorithm so that it is sorting words, and then besides sorting words in increasing order, you want to be able to sort words with different length, okay. So you need to, obviously you need to modify a bit the earlier algorithm, okay, the algorithm described by the figures, so that you can sort words of with a different length, okay. Third part, okay, the third part is to count the number of primitive operations carried out in the sort word, okay. So you just use a variable, okay, use a variable to count all the primitive operations, like what, multiply, like additions, like compare, like return, like calling functions, okay, add them up, okay. What I mean is keep track, okay, keep track of the number of primitive operation carried out. And then you want to count, okay, you want to count the number of primitive operations performed when you sort different numbers of words, okay. By the way, if you look at what I have provided you, there is also a list of there's also a word list, okay. There's a word list here. So the word list here have more than 100,000 words, okay. There are more than 100,000 words. So you need to basically like analyze the algorithm. So in this case, you will plot a graph. Plot a graph. The x-axis is n, okay. Y-axis is the number of primitive operation carried out, right? Then at different n, then you record how many primitive operations carried out, and then you draw the chart, okay. So basically that's what you want to do. So you can plot the graph using Excel, no need to use programs. But if you want, also can, I believe, using the Python matplot library should be quite easy also. Anyway, if you want to use Excel, also fine, no problem, no additional marks, okay. So those who want to do Excel, then in this case you just either print out the number of primitive operation carried out every time, and then save it, or automatic save the numbers the number in a file. It's up to you how you do it, okay. But at the end you want to draw a graph, okay. Want to draw a graph. So plot the best case, average case, and worst case, and then analyze the time complexity, okay. Analyze the time complexity for the algorithm, and then tell us what is the time complexity of the algorithm. in big O. Okay. Any questions?
Sir, I have a question.
Yes.
So for the, I mean, this assignment, right, is maximum 2 can be individual or
Yeah, can be individual.
can be individual. And also I
Yes.
want to ask, I mean, the data set provided is used for the, I mean, the third question or 1, 2, 3 actually can use this data set to actually validate the.
Yeah.
Because
Obviously, data set 2 and 3. The first one is a
number, yeah. And then
number you generate yourself.
Oh, okay, I see. And then I see the data set, right? Inside the data set is not only contain the, I mean, the alphabet number, is also have some special character. Is that, wait,
Is it?
I'm not sure.
This is rubbish character lah. You just delete it.
So I just filled out
This
this.
is, yeah.
Oh,
This list supposed to have only English words lah.
okay, understood.
So English words you yeah.
Okay, and then last question is, I mean, the third question is compare the, I mean, best average and worst case time complexity of 4 sort algorithms. So we need to compare 4 different algorithm. Is that, I thought we,
Just plot it for the sort word that you do. Okay. There's
okay,
only there are two script. Okay.
yeah.
The second you only count the second one.
Oh, okay, I see. I think that's all for me. Thank you, sir.
Okay.
Hello, sir.
Yes.
Please, may I ask 2 questions? The first question is
Yeah.
this. We were told that to calculate the average case involves some statistic knowledge. Can you just guide us or just explain briefly how to do this? Question 2.
You
How
just
many-
assume random. Just assume random.
Question 2. How many graphs are we expected to plot for this comparison?
Yeah, you can plot everything in a single. You can plot everything in a single Excel graph.
Okay, sir. What about the first question, the average case?
So the average case, then you get you calculate the average numbers in this case.
Pardon, sir? I didn't
Average,
understand this,
let's say you do 10, right? Let's say you do for specific n, you do 10, do 10 experiments, right? Then you add all the numbers and divide by 10. Can?
Thank you, sir.
Okay. Any other questions? But here, yeah, you the chart you do and let's see what's the result you get. Then draw it. So basically, yeah, just record what the numbers you count. So in the class, what we do is we write a function, right? So now what you do is just count it, right? Yeah, Kelvin, what is it about question part 3? Where are 3 different algorithms? There are only 2 algorithms. Oh, sorry. You mean here? Okay. Of the typo of the sorting algorithms. Okay, typo here. Thanks, Kevin.
Hello, sir.
Yes.
What is your response to Kevin's question? Because he didn't say anything.
You can typo. There's only one sorting algorithm, which is the sort word. Okay, so do this one. You can see my screen, right? Okay, any other questions? Okay, deadline is week 7. It's a Sunday. Okay, week 7 is a Sunday. But by the way, also record the execution of your program. I need to see that it is running. It can save some of my time instead trying to run your codes, execute your codes. Okay, and submit program report and also the recording together to e-learning. Okay, Ken, any other questions before we go to our we continue our discussion with for today? Grouping, you find your you find your own members, or if you want to do it yourself, then you can do it alone also. If you don't know your classmate, you can go to the that day the the Padlet. Okay, you can go to Padlet, or you forget the link, then let me see. Okay, you can find your friend or members. Okay, find your members that you want to work with. Okay, any other questions? Okay. We can do, yeah, you can do it individually if you want. It's not very difficult anyway, this assignment. Okay, no more question, right? Okay, then let us continue. Yeah, last week I've also give out an exercise, right? So I see some of you have did the exercise. Okay, so this is a question. So you only need to do A, B, C, and D, right? Do A, B, C, and D. So see your answer. Okay, I can basically question 1 and 2 is it's easy, so I won't be explaining them, right? So normally there'll be question easy and also difficult. So easy question normally you have 10, around 10 to 15 marks. In this case, it's 15. Okay, what's the time complexity for swipe? I think most of you actually got the answer, swipe. So let's see one of your friends answer, like Wu Feiyan. Okay, Wu Feiyan said it's a big O1. Justification assignment equals to 3 and there's no additional operators. Yes. Okay. So this is Wu Feiyan. I'm not sure it's a girl or it's a guy. Okay, if you look at the swipe functions, so this is the swipe function. So no matter how big is your array, there's always these three statements. You perform only three assignment. Okay. If you want, you can also count the array reference. Okay, referencing the array, but that it's not really matters. Okay, not really matters. Okay, so I hope everyone get the answer, especially those that didn't answer. If you didn't answer, but many of you actually get the answer right. Okay. Okay, so it's good to try out. You would rather try it out here than trying out in the test or exam. Sometimes if you didn't try out, you just look at the answer, seems like very easy, right? But then when it's the test or exam, then you try to answer it on your own, then you might face difficulty. So it's always good to try out on your own. Okay, questions D. Okay, question D, partition. Okay, question D, partitions. Okay, inside there's a loop and it is calling a function, right? Let us look at your answer. So most of you, okay, most of you put big O of n. Sorry, most of you put big O of n. Li Dengfei also put big O of n. Okay, Assad also say big O of n. Yeah, that's right. Okay, when we analyze, it's important also to look into if there are functions, you would want to find out what is this function. Okay, but luckily this swipe function is constant. So means it's fine. So not always is constant when it call another function, right? So you have to find out the function what it does. Okay, you have to find out what the function it does. So if this is constant, then fine. So this is always return is constant. So x equal or assignment is constant. Here another assignment constant. So what we need to look at is this. And beside you see here there's also a swipe. So luckily this swipe is a constant, right? The time complexity for the function is constant. If it's not constant, then it might change. Okay, it might change, affect the whole partition function. So now there's a for loop, and the for loop start from L until R minus 1. So if you assume L is the start of the array, and then R is at the end, then obviously then this for loop will run from item 0 to the last position of the array, right? So run n times, okay? You run n times, right? And yeah, luckily this swipe is constant, so big O of n, right? So the first few parts is not difficult, right? So if this is the test, most of you already got how many marks? 15, 25, 35. So the test is pretty easy at this point, if you look at it, right? So you could expect similar type of questions, okay? Similar type of questions in the test. I mean, similar in difficulty, right? Similar in difficulty, and you would similar type of questions, okay? Similar type of questions. But obviously, we won't ask the same question, okay? And any questions? No questions, then we will continue with our discussion on analyzing. Okay, let me look at your doctor. If it is in real test, do we need to write the complete method code for our answer and then analyze the time complexity? Okay. If you look at it is good to look at the marks. Okay, it is good to look at the marks. Okay, and for example, this one, what is the time complexity? First, it asks you the time complexity. Second, it asks you to justify. Then you just explain why you say it's time complexity, because yeah, just like what I've explained just now, right? So important, yeah. When you answer, it's important to look at the marks. For normally, okay, normally in whichever test I think in computer science, normally one correct point is like 2 marks normally, but for test maybe it's like sometimes it's 4 marks for one correct point. So you can roughly roughly guess how many correct point you want to put roughly, okay? Give you some idea, guidance. Okay, so look at the question and also look at the marks. So obviously, like question C, you don't want to just write the answer, right? You want to do some explanation also. Same with question D, okay? Same with question D. Okay, same with question D. Yeah, after you write the time complexity and then write some justification. Okay, like question A, then 5 primitive operation, obviously 10 marks, then obviously one operation correct is 2 marks. Okay, so this is some information to you lah. Especially when it will help you on how to answer the test or exam. Okay, no more questions? Okay, so so we continue with our discussion for today. Okay, today let us discuss a few more example. We'll use simple data structures that all of you should know. Okay, So we'll look at some of the function in these data structures and look at their time complexity. So this could finish by 7:30. We could finish this. Is quite introductory materials, okay? But give you a refresh or revisit on the data structure and the functions and their time complexity. Okay, so the data structures that we are looking at is stack queue and priority queue. Okay, yeah, hopefully I believe we could finish by 7:30. Then we will have a break. Okay, stack, as you know, is last in, first out. The last item that you put in, you will take it out, right? So the first item will be at the bottom of the stack, right? The last item will be at the top of the stack. Okay, so it will be last in, first out. Okay, last in, first out. So some common methods are push and pop. You already know, right? So there are other functions like top size is empty. So stack you can find in most programming libraries, Python, Java, C++, right? And the stack can be implemented using two either array or linked list. Okay, you can implement stack using array or linked list. So we'll look at some of these functions and see what are their time complexity. Okay, so for stack implemented using array, the time complexity for this function is big O1, push is also big O1, pop is also big O1. Okay, so the stack in this case, right, is implemented using array, right? So we have an array, right? And then we implement stack, right? So if we implement stack using an array, so how would just look at this example, for example, size. How would we want to implement the size? Anyone? How we want to? Yeah, size will tell us the numbers of item in your stack, right? Stack will tell us the number of item in our stack, right? So how do you want to implement this size method? Okay, how do we want to implement this size method? Come on, quickly. Many of you are programmers in many big companies. This is very simple questions. Return the index. How to return the index? The last one minus first one. Okay, so okay. Is there any other answer? Okay, so size. Okay, size obviously keep track of the number of items in your stack, right? So we implement our stack using array, right? So when we put, let's say when we push our item, then we'll put it initially. Our stack is empty, right? So initially, then when we push them, obviously we push it in the array in item number 0, right? You push it again, then you'll be inside here, right? So one way to implement the size is every time you push the item into the stack, you use a variable to keep track, right? For example, let's say length, right? Let's say length. Initially, length is equals to 0, right? Every time you push, okay, every time you push, then you have a push function. Every time you push, you increment the length, right? Then when someone calls size, then what you do, just return length, right? Okay, size will just return length. So every time you call the push, you have to increment the length. Okay, so in this case, your length your size will always constant, right? Your size only the number of primitive operation is, in this case, is constant. Obviously, there are other way which is not that very efficient to implement size. For example, if you didn't keep track every time if you push item into the stack, what happens if you didn't keep track of the by adding the length? What happened? Then in this case, you must have a for loop to look through to check the item in your array, see how many items are filled, right? How many items are filled? Then from there, then you return. So if that is your implementation, what is the time complexity for size? What's the time complexity? The time complexity, if you use a for loop to check the length of the size of your stack, the size of your stack, then in this case, it will be big O n already, right? Because you have to go through check, and if it's already at the end, then you have to check n times, right? So what I'm trying to say is the time complexity given here depends on how you implement your functions or method. Okay. So similar with push. Okay, similar with push. Every time you push, you must have a variable that keep track of the top of the stack, right? So initially, the top of the stack is pointed maybe either 0 or -1. Okay, depends on implementation. So then every time you put in, then you fill up, keep track of the top of the stack. If there's no variable that keep track of the top of the stack, then every time when you want to do a push, then you have to check where is the top. Okay. Similar with pop, right? there must be a variable or pointer that keep track of where is the top of the stack. Okay. So that when you pop, you know where to pop. When you push, where to put in, right? So in this, if you keep track of the top of the stack, then obviously you will get this time complexity, right? If you implement it differently, then you have to look at how is your implementation. If, like what I explained, you didn't have a pointer or counter that keep track of the top of the stack, then end up you have a time complexity of big O n, right? So all this depends on implementations. Okay, no, actually it's quite easy. Okay, so for these data structures, so just to revisit with you all the basic of the algorithms. Okay, for similar for linked list. Okay, linked list is similar. So for a linked list, you want to know where the list start, right? Where the list start, and you might also want to know where's the tail of the stack. Okay, tail of the list. Okay, you want to know the tail of the list. If you look at the list right now, there's a pointer there's only one pointer pointing in one direction. Meaning, if you only have a pointer pointing to the tail of the list, then you have problem going in front, because if you look at this figure, there's no pointer pointing back, right? So we will want to have a pointer pointing to the head of the list and also at the tail of the list normally. Okay, so for then for pop, then you just take the tail and then pop it, right? And also for size, if you look, you want to keep track of the length. Okay, how many items in the stack. Okay, so that is for stack. Okay, that's for stack. As for queue, okay, queue stack is a last in first out, right? This queue is first in first out, right? Items going in will be coming out first. First coming in will be coming out first. Okay. Common methods are append and remove. So when you append, you add it at the end at the end, right? And when you remove the one at the top. Okay. Similar like stack queue can also be implemented using array or linked list. Okay, so for, let's say we implement the queue. Okay, let's say we implement the queue using an array, right? So, okay, so in this figure, we have item already have item in the list. So when we do a remove, which item will be removed? Okay, item in the position 0, right, of the array, which is item A, right? Thanks Sapti and just now Maina, okay, Maina who answers. Okay, so after we remove okay, now position 0 is empty. So what should we do? Okay, after we implement queue using an array, right? Let's say we do a remove. We remove item A. Okay. So after we remove item A, what should we do? Okay. Okay. Right. So Sapti and also Kengun tell us the right answer, which is either move your pointer to the next item or you keep track of the index of the first item. That's right. So meaning, okay, meaning we want to have either a pointer that point to the head of your queue. Okay, early on the head of the head of the queue is at position 0. After we remove item A, we want to move our pointer or index, okay, to the next item, which is point to the position 1 of the array, right? So this is the most efficient way, okay, to do the task. If you implement it like this, obviously the time complexity for remove will be big O1. Why? Because every time you remove, you take the item out, which is one which is constant, right? And then you move your pointer or point your index to the next subsequent position of the head of the queue, right? So total 2 operations. No matter what is the size of your list, there are only constant amount of operation carried out, right? So this is the best approach to implement the queue, right? Obviously, there are other approach. One approach that will take more time is after you remove, you shift all the item, okay, right? You move B to position 0, you move C to position 1, you move D to position 2, you move E to position 3, and so on. So if you do it like this, what is the time complexity? Yeah, thanks, Kingbun. So if you do like what I mentioned, you shift them, you end up with big O(n). Thanks, Dr. also, right? So your implementation, how you implement your function is important. Okay, how you implement your function is important. Okay, similar with append. We would want to have either a pointer or a variable that keep track of the tail of your queue. Okay, the tail of your queue. So in this case, next time you append, you will move your pointer one position. Okay, when you append, you point it here and then add your item here, right? So this is the most efficient way to implement the queue. Okay, so one thing I didn't mention just now is, so if you continuously remove the item, and the head of your array, right? The head of your array will be empty, and then you continuously append, then eventually you add the end of the array, right? So one way is to, after you reach the end, you continue back at the position 0, okay, position 0 of your array, right? So this is what we call the circular circular array, okay? Of for instance, OP, then after you append again, you append at position 0, QR, and so on. Okay, so circular array. So so in this case, you also might want to make sure when your array is next to the tail of your array is next to the head, then obviously you must know that it's already full, right? So that if you attempt to append the list, then it mustn't do that, right? Okay, so these are some implementations how we want to write our algorithm for append and also for remove. And how we do it will obviously affect the time complexity. Okay, we still have some time. Okay, so these are set and queue. So the third is priority queue. So priority queue is similar to queue, but now there's an additional criteria. There's a priority attached to each item. Okay, attached to each item. So priority queue example is one obvious one is in airline, right? Those who have business class has a higher priority, right? Or first class has a higher priority than economic class, right? So those who with higher priority can do something earlier than those with lower priority. So normally there will be a key attached with an object. Okay, there's a key attached with the object, and the key normally is we use an integer value, right? Integer value with normally a smaller integer value have a higher priority normally, right? But if you want to implement it where higher value have a higher priority, is also fine, right? No problem. Okay, when implementing priority queue, right? So you have to make sure all these true. Okay, all these properties defined properly. Okay. So why do we need to define this? Because for priority queue, obviously we want to define our own priority for our own objects, right? You have your own object. Then you have to define how to compare the priority, right? So for example, airline, then maybe you said you define by the price of the ticket, for instance, right? Higher price, then you will assign higher price of ticket. You assign a lower value key to that person, right? So this one way to do it. For example, for airline tickets, right? So then you have to define how to compare the price of the ticket. Okay. So those who did, for instance, interface comparable, then you know if you do it you do these things before, right? Okay. So these are for priority queue. These are some of the methods, okay, in priority queue that you can find in priority queue. Some of the common found methods or function. Okay, so this is an example of priority queue. The first value is the key, okay, that determine the priority. The second item character is just an object. So in this case, it's a character. It's normally it is any object. It can be any object, right? Okay, min will tell us performing the min operations will give us you return the object with the highest priority, which has the lowest value. So we have 3, 5, 9. Obviously, the one with the highest priority is this one, right? That's why you get 3B. Okay, so so we'll insert the item into the priority queue, right? Min, then we'll return the item with the highest priority. For priority queue, there are few ways to do it. There is we can implement it using an unsorted list, sorted list, or using using heap. Okay, using heap. Okay, so if it's unsorted list, right? Let's say unsorted list or unsorted array. Okay, let's say we have an unsorted array. That will be easier to see. Okay, so for unsorted list, why mean the time complexity of unsorted list implementation of priority queue is big O(n)? Anyone? After we finish this is the last slide already. After this, we could yeah. Thanks, Tengwen. Sapti, thanks. Okay, after finishing this slide, we will have a break. Okay. So yeah, just now 2 of your friends have answered, right? Why always the same person answer? Others can try also, right? So the answer is correct. If it's unsorted list or array, you have to check all the items. Your array has n items, then you have to check one by one to see which one is the minimum. If it is sorted, if it's a sorted list, right? All sorted array, all your numbers, right, is in increasing order, for example, right? Let's say okay. So min is obviously is a constant. Is always at the always the first item, right? First item of your array or pointed by the pointed to the head of the list or array, right? So okay, so this can be easily understand, right? So min size and okay, insert. So let us look at insert. So insert, since this is the first one is unordered, this unsorted or unordered. If it's unordered, insert is very efficient because it's just simply add. So if it's initially it's empty, you just put it here. Then after that, you put it here, put it here, put it here. You just simply put it. As long as there's a position which is not filled, you put it in, right? So that is why insert is very efficient. It's always take constant amount of time. So no matter what is the size of your list or array, it always take constant amount of time. But on the other hand, for sorted list or array, you have a value. Okay, you have a value. Okay, you have a value x. You have to insert to the list. Okay, you have to insert a list. So you need to know where to insert, right? So if it's 8, then you have to check. Okay, you have to check where to insert, right? So that is why it take big ON for sorted list. Heap. Okay. Anyone still remember what is a heap? Anyone still remember? Forget already. Okay, heap is a tree structure. Okay, heap is a tree structure where heap is a tree structure where the top of the root of the tree has the smallest value. Okay, so let's say 1. You can have 3, 4, 5, and so on. Okay, the top has the lowest value, right? The top has the lowest value. So since the top has the lowest value, mean is every time we want to get the mean, we will just remove the root of the tree. Okay, so removing a root of the tree is very easy, since normally we will have a pointer that or variable that point to the root. Okay, insert. Okay, insert is for insert, the time complexity is log n. So how to insert? So normally insert mean. So normally insert, we will want to insert if this position is filled, then we'll insert it here and then move it upwards. Okay, so this is how we insert it. Then so when you insert at the leaf, then you move it up. So the highest it can move is so this is a tree. So the numbers of operations is, in this case, is log n, right? So I'm not going to discuss further for heap, right? So basically this is the structure. Okay, now it's 7:20. Okay, then we could have an early break. Okay, have an early break. Okay, so can we break now and maybe fine. Okay, we come back maybe at 8:10. Okay, we come back at 8 o'clock, 8:10. Okay, we come back at 8:10. Okay. Any other questions? Else we will take a break. Okay, no more questions. Then I'll temporarily end the session. Then later on, please join back. Okay. Okay, enjoy your dinner. See you later.